Find the area of the circle with the given diameter. If the diameter is 4.5 and the radius is half of that, which is 2.25. So we need a radius squared times pi. 2.25 squared is 5.0625, and then we have pi to leave it in terms of pi. Find the formula for the volume of a cone with a height and radius shown. Explain your reasoning. Well, if it was a cylinder, it would be radius squared times pi, and then multiplied by the height. But it took 3 cones to fill up the cylinder. So the cone is a third of the volume of a cylinder. It's similar to how the pyramid took up a third of the volume of a prism. The cone takes up a third of the volume of a cylinder. A circular cone is a three-dimensional solid that consists of a circular base on a plane and a point not on the plane called the apex of the cone. All segments that join the point to the base. The height of a cone is the length of the segment that joins the apex of the cone to the plane containing the base and is perpendicular to the plane. Here I have a cone with a radius of 2 and a height of 6. If I make this an oblique cone, you can see that the volume does not change. On page 369 in your workbook, you have more to add to this graphic organizer. We have the right cone and the oblique cone. Both of them have an apex at the top and a base at the bottom. They have a radius and a height. The volume is found by 1/3 the base area times the height, or more specifically, we can write 1/3 the base area is found by doing radius squared times pi, and then multiply by the height. R is the radius, H is the height. This symbol stands for pi, which is approximately 3.14. The V stands for volume, Fill out that graphic organizer to help add to your notes for the formulas. What is the volume of the cone shown on card J? We have radius squared times pi times the height, which is 4. That would be if it was a cylinder, but we still need the 1/3 because it is a cone. We'll start by squaring 1.5. That is 2.25. Then we'll multiply that by 4, which is 9. Oops. A third of 9 is 3. So the volume of this cone is 3 pi centimeters cubed. Remember, volume is units to the third power. 3 says find the approximate volume of the cone shown on card L by using 3.14 for pi. This is a cone, so 1/3 radius squared. The radius in this case is 3 times pi times the height. 3 squared is 9. 9 times 3 is 27. A third of 27 is 9. But we're replacing pi with 3.14. So 9 times 3.14 is 28.26, and that would be in units cubed. Remember, this is the approximation, so we replace pi with that value we're approximating it as. The pyramid on card Z has a base with an area of 12 centimeters squared. What is the volume of the pyramid? Pyramids are 1/3 the base area times height. This one tells us the area of the base is 12, and the height is 4. 12 times 4 is 48. 48 split into 3 parts is 16. So that is 16 centimeters cubed. What is the volume of the prism shown on card B? This is a rectangle base, so the base area is going to be found by 12 times 3.4, which is a base area of 40.8. To find the volume, we do the base area times the height, which is 9.6. And the volume comes out to 391.68 feet cubed. The volume of an oblique pyramid is 324 centimeters cubed. The area of the base of the pyramid is 27. What is the height of the oblique pyramid? Well, we have volume equals 1/3 the base area times the height. The volume is 324, and the base area is 27. A third of 27 is 9. Divide both sides by 9. We're left with h on the right side, and 324 divided by 9 is 36. So the height would be 36 centimeters. The volume of an oblique cone is 192 pi cubic feet. For a cone, we use 1/3 the radius squared times pi times the height. It says here that the volume is 192 pi. It also says the diameter is 24. So if the diameter is 24, the radius must be 12. And we need to find the height. Well, 12 squared is 144. A third of 144, or 144 divided by 3, is 48. Then we'll divide both sides by 48 pi. So the pi's divide out. And 192 divided by 48 is 4. And on the right side, we're left with h. So that is 4 feet for the height of the oblique cone. Finding volumes of cones and pyramids are very similar in the sense that they are a third of the cone, or a third of the cylinder, or a third of the prism that they match.